So, ito yung mga itsura ng mga resistors natin kapag, for example, maglalab tayo. Actually, we have this type of resistor pa. Itong mga to. Ito yung mga makikita nyo doon sa mga makakapal or matatabang TV. Hindi ko alam kung actually parang wala nang ganitong available sa mga electronic shop. Pero itong mga color-coded. Okay, meron tayong table dyan, yung PRGV, their corresponding multipliers. So, nabibili pa yung mga yan. So, itong mga to, ang tawag natin dito ay mga carbon film type. Okay? They are carbon film type. Pero ngayon, kapag bibili ka ng mga resistors sa electronic shop, ito na halos ang bibigay nila. Itong mga white na parang plastic. Okay, meron din tayong variable resistors and ito potentiometer. Yung mga variable resistors natin, we can vary the value ng resistor. For example, nagkukonduct tayo ng laboratory activity and we have to change the value of the load once in a while from, let's say, ang range ay 20 ohms, 20 kilo ohms to 50 kilo ohms. So, meron siyang parang point na pwede mong i-adjust. Okay, so ito yung symbol natin ng variable resistor. Pwedeng lumitaw yan sa mga problems natin. Okay, so ibig sabihin we can vary the value of the resistor. Pwedeng mag-iba-iba yung value niya. Depende dun sa rating na nakalagay na sa kanya. So ito naman yung symbol natin sa potentiometer. So ngayon, sa mga gadgets natin, TV, hindi na natin actually makikita itong mga yan. Okay, na naka-embed. Okay, ang makikita na lang natin is an IC circuit wherein yung mga resistor natin are embedded dun sa ating circuit, IC circuits. Okay. Maliban dun sa equation natin ng resistance, which is equivalent to rho L over A. Okay. Which is, sinasabi kasi dito sa formula na to na yung resistance natin ay depende sa resistivity ng material. Meron tayong mga event or cases that the resistance or is actually affected by internal or external conditions. So, sa internal, itong ating resistivity constant. External conditions, ano yung external conditions? Like temperature. So, yung ating resistance value ay affected siya sa change in temperature. I will have a separate discussion on that matter. No? From the meantime, ito na muna tayo. Ito na muna yung gagamitin nating equation and yung equation ng Ohm's law, syempre. Ayan. Kapag sinabi natin na, or kapag pinag-uusapan natin ang load natin or resistor in terms of Ohm's law, meaning to say, kapag pinlat natin yung IV characteristic, yung I versus voltage characteristic ng resistor na yon that obey Ohm's law, it will have or ang magiging itsura ng ating graph ay linear or linya siya. Ito sa A. Kasi R is equal to V over I. So, rise over run. So, this is a first degree equation. And yung V over I is actually the slope. Ito, slope ng ating resistance. So, since R is equal to V over I, it is a first degree equation, meaning to say that the highest exponent of the variable is 1, raised to 1 kasi sila. Therefore, we expect that the plot of the resistance is a line. Okay? With 1 slope. Ayan. So, obviously, kapag plot mo kasi yan, yung V versus I, or yung tawag natin dyan ay IV characteristic, ang makukuha mo ay linya. Okay? And this equation is based on Ohm's law. So, yung mga resistor natin, okay, yung mga load natin na nag-o-obey ng Ohm's law, they are actually a linear resistor. Pero we have loads, other loads like the diode and light bulb that does not obey Ohm's law because kapag pinlat natin yung kanilang current versus voltage characteristic, curve siya. Okay? Let's say you can have a equation in the second degree or third degree. Okay? Kasi hindi sila nag-o-obey ng Ohm's law. In our discussion dito, okay, kapag nagsosolve tayo, usually yung mga resistors naman natin, they are linear. Okay? We consider or we are yung mga problems natin, yung mga loads natin ay linear resistors. Okay. So, meron pang isang parameter na kailangan natin tandaan. That is conductance. Ito yung reciprocal o yung opposite ng ating resistance. So, kung ang resistance, ability of an element to resist or oppose the electric current, ito naman to conduct. The ability of an element to conduct electric current. And that is measured in mho. So, mapapansin nyo, baliktad lang siya ng ohms. Kasi ohm. Tapos, ayan. Ewan ko bakit ganyan. Or, ang ginagamit ng karamihan ay Siemens, or that is capital letter S. So, if it is the reciprocal, okay, so, ang symbol natin for conductance ay G. Take note, symbol for conductance ay G. So, reciprocal siya ng resistance, kaya 1 over R. Or, it is equal to I over V. Paano nangyari yan? So, V is equal to IR, right? So, R is equal to V over I. So, if sa substitute natin, conductance is equal to 1 over R. So, sa substitute natin, 1 over what is R? This is V over I. Or, kapag in-arrange mo to, that would be I over V. Ayan. Kaya ganyan siya. Ito. Ayan. So, 1 Siemens is equal to 1 mho, or that is 1 ampere over volt. Okay. Ito naman, I is equal to GV. Okay, paano nangyari na naman yan based on Ohm's law? Okay, we know that V is equal to IR, right? So, I is equal to, ito lilipat, V over R. Okay, since, okay, G is equal to 1 over R, okay, or, pagpalit natin, R is equal to 1 over G. Okay, papalitan natin ngayon ito in terms of G. So, I is equal to V over, what is R? 1 over G. So, I, aakit ito, okay, if we arrange. So, V times G. Or, that is I is equal to G times V. Ayan. So, ayan siya. So, we can, substitute yung ating conductance, okay, dun sa mga Ohm's law equation natin in terms of resistance. And we can derive, okay, equations in terms of conductance using Ohm's law. Okay, if you remember, we have the equation of power in the instantaneous power in terms of the voltage and the current. Okay, voltage across the element and the current through the element. Ipa natin kino-coin yung resistance, okay? Basta meron tayong element. Okay, now we can use Ohm's law to generate equivalent formula for our power. Okay, since V is equal to IR, ganyan na muna, we can substitute. First, pwede nating palitan itong V in terms of IR. So, I times R times I. So, P is equal to I times I squared times R. So, this is another equation. Ito siya. Next, kung ang papalitan naman natin ay si current. Okay? So, ito, this is Ohm's law. Okay? Ito I is equal to okay, I is equal to okay, V over R. Ayan. So, balikan natin ito. Okay, P is equal to V times I. P is equal to V. Palitan natin ngayon si I naman. V over R. So, P is equal to V squared over R. So, we have 2. Ayan. So, ito yung nauna dati. Tapos, ito na naman yung mga equivalent equation natin in terms of Ohm's law. So, it's true kapag in terms of conductance natin. Okay, palitan nyo lang. So, again, tignan natin to. So, conductance, P is equal to V times I. Again, kung papalitan natin yung I is equal to, okay, I is equal to, okay, diba, since I is equal to V over R, ngayon palitan natin si R in terms of conductance. I is equal to V over 1 over R, 1 over G. Okay, so that is equal to V times G. Okay, so ngayon, I is equal to V times G. Palitan natin ngayon si I ng V times G. Ayan, P is equal to V squared times G. Ayan siya. So, yun yung ating equation. So, kung ang papalitan naman natin ngayon ay pinalitan natin yung I, ang papalitan naman natin ngayon ay si V. So, V is equal to I over G. Ayan. Ito naman ang gagamitin natin. So, P P is equal to VI uli. Umpisa ka lagi uli dito sa original equation natin. So, P, palitan natin ng V, which is I times G. Terms of conductance yan, obeying Ohm's law. And then times I. Okay. P is equal to I squared over G. Ayan siya. Ayan. So, yan yung mga equivalent equations natin ng power in terms of Ohm's law sa resistor at saka isang set para sa conductor. Take note, ito, importante itong dalawang ito. Yung power dissipated sa resistor, yung power ang pinag-uusapan natin hindi yung resistor mismo. Kasi sa resistor, if it obeys Ohm's law, it is linear. Pero kung power, yung parameter na power dissipated doon sa resistor, ang pinag-uusapan natin, non-linear siya. Bakit natin nasabi yun? Tingnan nyo naman po ang mga equation na na-derive natin. I squared R, V squared R. In terms of conductance, I squared over G, V squared over G. So, second degree equation tayo, it is not linear in that case. So, they are not non-linear functions. Okay? Yung resistor mismo, okay, obeying Ohm's law, linear siya. Diba? Pinakita ko yung figure. Pero kapag pinag-uusapan natin power, since we have second degree variable doon na naka-raise sa 2, ayan, they are non-linear. Next, take note, R and G are always positive. The value of resistance, conductance are always positive quantities. Hindi sila kamukha ni current, power, ano pa, voltage na meron tayong sign convention na sinusunod. Okay. Kasi si R at saka si G, resistance and conductance are characteristics. So, they are positive. So, meaning to say, kapag kinuha natin yung power dissipated on resistor, they are always positive. Diba? So, it follows or it confirms the idea na yung mga resistor natin ay positive elements. Sinabi ko na kanina, no? Resistors are load. We consider them as positive element because their power dissipated is positive. So, kapag positive ang power, ina-absorb nila yung power. They are not capable of generating energy. They are the one who absorbs the energy dun sa ating circuit. Okay, so hanggang dyan na muna.